Hello my dear students, welcome everyone to India's first animated live tuition. I want everyone to keep yourself ready over there for a brand new session. I welcome all of you to 90 plus My Tuition app family. So keep yourself ready over there guys, get ready for a brand new session. So keep a bottle of, okay fine. So Ramzan, right? No need to keep a bottle of water. Good evening, good evening, good evening everyone. Fine. So all of my students have joined, I guess. So get ready. How you will get ready? Okay, you'll be like, okay, fine, I'll get ready. No, what do you have to do? Please do revise all the particular portions and topics which we have discussed in the previous session. So questions are coming your way. Please do get ready for the questions. I'm going to shoot some questions to all of you. Okay, to all of you. So everyone, be ready to face the questions. I hope you have revised the portions which we learned in the previous session. So who all have joined today? Who all are new? Just joined today? Raise your hand real quick. Let me know. Sir, I just joined today. I was not there in the previous session. This is my first physics session. Rehan, Shlok, right? Shlok, Gauri, Narasimha, Aurelia, Jia. 5 students, right? Janita. Okay, 6 students. Fine. So guys, what you have to do is, in previous session, if you have any query, what you'll do for my new students? My all students know it already. You have to raise your hands and ask me directly, or else drop your queries in the chat box. Please don't forget to do that. Okay, clear everyone? And also for the sessions which you missed, what you have to do, please do contact our academic counselor team or the admin team. What they'll be doing, they'll be providing you with the links of the live sessions which you missed. Important. Please don't forget to do that. So please do contact them. Please do let them know, sir, yeah, I have just joined today, or I have missed a lot of sessions with respect to the chapter force and pressure. We didn't miss much, right? So for my new students, you just have missed 3 sessions, right? Barely 3 sessions regarding the chapter force and pressure. So don't worry, you can cover it up very easily. So please do reach out if you have any queries, concerns and all. Drop your queries and concerns in the chat box. So today Judy ma'am will be assisting you guys as your support tutor, and Rin sir is our host, and we have a student coordinator team as well. So guys, please do reach out. Don't hesitate, okay? How the tutor will feel. Is it bad to ask such questions or such queries, doubts? No, it's okay. Completely, it's fine. Please do reach out if you have any doubts. So unmute Janita, right? Yes. So before we go, Janita, how should I pronounce your name?
Sir, Janita, sir.
Janita, perfect, right? So Janita, do you have any question for me?
No, sir. You asked before to hand raise if you are new for the first
Got it. I'm just asking casually. Any questions for me? Any queries,
no,
concerns? No?
No, sir.
Brand new
No,
session
sir.
of 90 plus My Tuition app family. No questions? Curious
no,
to know
sir,
about it?
I attended other subjects.
Okay, you have attended other subjects. Fine. So you find it helpful, animations and all is very helpful or what?
Yes, sir, it is really helpful, sir.
Fine. So please reach out, guys. So let's begin, right? So let me ask my first question to Navneet. So Navneet, please do unmute. Navneet is like, yeah, I expected. You'll ask the first question to me. I expected this. So unmute Navneet. Hi Navneet.
Hi, sir.
How are you doing?
Fine.
Just fine. Not that good?
Marvelous.
Amazing. Fantastic or what? So Navneet.
Yes,
you are not fasting, right? Anyways, you have some extra energy, I expect. So anyways, so Navneet, tell me, what is muscular force? What is muscular force?
Muscular force is the force applied by our muscles.
Force applied by our muscles.
Yeah.
Caused by the action of the muscles in our body. Perfect. Then?
Yes. It interacts between the object and our body.
Yeah. So since there is an interaction between the muscles or our body and the object, we can call it as
muscular force.
We can call muscular force as what? As a contact force. Yes. Fine. Very good. So Avantika was there in my previous session, I guess. Unmute Avantika on top. Yes. Hi Avantika.
Hi, sir. How are you, sir?
Yeah, I'm good. Avantika is like, sir, please don't ask me questions. We can have just an interaction. I hope you're doing well. So Avantika, tell me an example of a non-contact force. Go ahead.
Non-contact for magnetic force.
Magnetic force.
Gravitational force.
Gravitational force, very good. Then?
And electrostatic force.
Electrostatic force. Very good. That's it. Only three forces, three non-contact forces. Now Avantika is like, yeah, sure. Only three are there.
Yes, sir.
Fine. So please do let me know, guys, if you have any concerns. So fine. So whom should we call next, ma'am? Those who were there in the previous session. Okay, Ashika, right? Ashika is hand raising. Sir, please call me. I'm so confident to answer. So Ashika will be telling me an example of an Yes, Ashika, tell me an example of an electrostatic force. Three examples.
Electrostatic force.
Yes.
Batteries.
Batteries. Oh God. What is that background noise coming up, Ashika? Ashika, do one thing. Type three examples in the chat box. Quick, real quick. Type three examples of electrostatic force in the chat box. Now, please unmute. Whom should we call next? Dion Thomas down there. Dion Thomas, were there in the previous session? You were there, right? So unmute yourself.
I was not there in the previous class. It's my first physics.
First physics session, fine. So, Dion Thomas, any questions, queries for me?
No.
No, right, fine. So please do reach out if you have any concerns. Whom should we call, ma'am, next? We can call Joshlin. Joshlin, you were there in the previous session, right?
No, sir. I was not there in the previous session.
So this is your first physics session or what?
No, sir. This is not my first session, but I was not in the previous session.
Okay, fine. So we'll be checking out. You sure, right?
Yes, sir.
Fine. So Joshlin, can you give me some examples of an electrostatic force?
Electrostatic force.
Ashika is typing in the chat box. Good. Go ahead, Ashika. What is this printer? Ashika is typing. Example of electrostatic force, printer. So in the printer, the printing machine and the paper will be rubbing each other, so they'll be producing electrostatic force or what? Unmute Abhirami. Balloon, attracting balloon, fine. Not balloon, right? So unmute Abhirami. Hi Abhirami. I can't hear you. Unmute yourself. You are muted. Abhirami is like, yeah. Yes. Hi sir. Yeah, now I can hear you. Fine. So Abhirami, give me an example. Give me an example of a contact force. Three examples of contact force. Three types of contact forces. You have different types of contact forces, right? Contact forces. Which are the contact forces? We have learned it already. Magnetic force is a contact force.
No.
Over here, it's perfectly written. Non-contact force is magnetic force. And you are saying magnetic force is a contact force.
No, is it non-contact or contact?
This is non-contact. I'm asking you about contact force.
I'm not sure if I was there in the last class.
It's okay. It's okay. Give me your answer.
I think.
You think? Some of you are typing in the chat box. Very good. Yes. Go ahead. Fine.
Frictional force.
Frictional force is a contact force. Very good. Then lifting a bucket is
like normal force.
Normal force. What is that normal force? I don't know about normal force and all. So yeah, it's okay. So unmute Sarah, Shija, Sony. Guys, since it's just the first 2-3 sessions, I'm like, okay, fine, it's okay. You can do like this, but The next time everyone will be getting impositions. Impositions are coming your way. Unmute Sarah, Shija, Sony. Sarah, Shija, Sony, go ahead. So, frictional force is already shared by Abhidami. So, go ahead with the remaining contact forces.
What's contact force is muscular force.
So, muscular force and frictional force is an example for contact forces. We have learned about muscular force and we have learned about frictional force as well. So, can you give me an example of a frictional force? Maria, Shija, Sony. Unmute Maria. Hi Maria. Give me an example of a frictional force. We have learned, we have seen some animations for a better clarity.
So you call my sister, but you're telling me to unmute.
Yeah, it's okay. Go ahead.
Muscular force, right? Okay,
Frictional force, frictional force. Oh, go ahead. So Maria is like, sir, I was about to answer and someone muted me. What should I do? And now if you ask me, I'm confused with the answer. Isn't it? Fine, think about it. Frictional force, interaction between two objects. So there is a contact between two objects, right? Direct interaction is there.
Erasing the pencil mark?
Increasing the?
No, erasing the pencil mark.
Erasing the pencil mark is an example of a frictional force, fine, but still, you can just consider eraser is moving ahead when the force of friction is against the direction of motion. Anyways, Judy ma'am is like, that's not a fair example, but anyways, it's okay. Fine. So, anyways, we'll ask, whom should we ask, ma'am? Fia. Okay, hi Fia. Fia, you can unmute yourself. Without unmuting, if you say hi, just your family will be listening to it. I won't be hearing it. I hope you know that.
Hi sir, how are you?
Yeah, I'm good. Do I look good or what? So, do I look unhealthy or do I look very emotionally low or what?
No sir, you look.
So, guys, are you revising? So, Fia, have you revised? Please be honest. Have you revised?
Yes sir, I was absent on the last session, but they sent me the video, so I revised through the videos. So
very good. Applause for Fia. Guys, the thing which I say every day, if you have missed a particular session, please do contact, get the link of the live session. Please do watch it. Important. So Fia missed the previous session. What she did? She didn't sit idle over there. She have contacted the admin team, got the link of it, watched the session. Very good. So, Shia, can you give me an example of a frictional force? Fia, right? Okay, not Shia. Fia. Pardon? Yes. Go ahead.
an
Example. Sophia is like, yeah, I prepared a chapati, so I applied some frictional force to change its shape. Is it Fia? Magnet sticking to the fridge. Halimvi Shaju is giving strange examples. Yes, Fia. Do you remember the animations in the previous session which you have watched? Any particular?
Yes, sir.
Yes. Tell me an example. Yes, Bhadra is giving a very good example. A man walking on the road is an example of the frictional force. Yes, very good. Then, Fia, do you think the movement of vehicles or the tires of the car over the road is an example of a frictional force or what? What do you think?
No.
No?
Like the object which are contact on the surface.
So when the tires of the car is rolling over the road,
Touching the road.
it is touching the road, right?
Yeah.
So there will be a frictional force, right?
Frictional. Yes, sir.
Yeah, that is a perfect example for a frictional force. So guys, when you learn about forces, don't just learn about the forces. Also, you have to learn some examples related to it. Got it? Fia? Not just to Fia, everyone.
Yes, sir.
Fine. You can mute yourself. Yeah, make nice sharing. Rolling a ball and it suddenly stopping is an example of frictional force. Obviously, frictional force will always act opposite to the direction of motion. It will be acting opposite to the direction of motion. Suppose this is the surface and the ball is rolling from this direction to this direction. Frictional force will be acting in the opposite direction. Fine. Writing on notebook or blackboard is a perfect example of frictional force. Yes, flying on airplanes. When the airplanes are flying on the air, everyone will be thinking, where is the contact? There will be a contact with the air and the surface, bottom part of the airplane. So when the airplane moves ahead, the air pressure will be there, which is acting in the opposite direction. That is also an example for a frictional force. Fine. So anyways, let's go ahead. So guys, I hope you remember the non-contact forces as well. That is the magnetic force, electrostatic force and gravitational force. So with respect to magnetic force, we have learned that it is a force exerted by a magnet. It is an example for non-contact force. Force exerted by a magnet on a piece of iron is also a non-contact force. So after that we have learned about electrostatic force. I hope you remember. We have seen the animations. A child was rubbing a comb, right? Comb or a pen? Comb. She was rubbing a comb to her hair, and what she did? She tried to stick some piece of paper into it, isn't it? So we have checked out some examples. I hope you might have tried. You might have rubbed a pen on your head and tried to stick papers, right? What is the reason for it? It's none other than static force. So this is the best example for electrostatic force. So drop your query in the chat box, Kevin. Real quick. Type it down in the chat box. Fine. So we have learned about electrostatic force. That is the force exerted by a charged body on another charged or uncharged body. It is known as an electrostatic force. Fine. Anyways, let's go ahead. Then after that, we have learned about gravitational force. So everyone is very confident when I discuss about gravitational force. Yes, sir, we know it. We have researched about it in detail. So always in our Earth. So we know this particular feature which is there for our Mother Earth. When we drop something, what happens? Always it goes down, right? Why? Someone is pushing over there, right? Someone is pushing over it. Isn't it? No. So actually it's the result of gravitational force. So every object will have a tendency or will have an attractive force towards the surface of the earth. So this particular force is known as gravitational force. As an example, we have seen the animation when the trees were shaking, the apple and the mangoes were falling down from the trees. Why can't it go up? When it gets detached from its twigs or branches, when it gets detached, why can't it go up? The only reason for it is none other than the gravitational force. Objects or things fall towards the earth because it pulls them. This force is called the force of gravity. So this is an attractive force. We have learned it already. Every object in the universe, whether small or large, always will exert a force on every other object. Cause of what? Cause of what? Cause of the gravitational force. We have learned it already in the previous session. I hope it is clear for everyone. So everyone is thinking why sir is going real quick. It's just that we have discussed all these portions in the previous session. Okay. So if you guys have just joined today, if you feel like okay you need a detailed explanation for all those topics, what you have to do, please get the links of the live session which you have missed, and using that you can watch. You will get a detailed explanation of all those particular topics with detailed animations as well. Now let's move on to a brand new topic today, that is none other than pressure. Guys, are you feeling the pressure or what? Pressure on your head? Okay, we are on 8th grade, a lot of topics to learn. We feel a lot of pressure, so please do wind up the session. Let's have some fun over here. Let's go play cricket, football, or in some indoor games, chess. Isn't it? So everyone is like, yeah, fine. We'll be happy. Maria, enough. It'll break your neck. Maria is like, yeah. Fine. Yes, sir. So over here, we are going to go ahead with the topic pressure. Kevin is like, no, sir. Kevin, what's your query? You have hand raised, right? Where's your query? I can't see your doubt in the chat box. Judy, ma'am?
No.
Newton discovered gravity, yes. No, sir. Okay, Kevin said, no, sir. No, sir. What? You don't want to play or what? Fine. Anyways. So, regarding pressure, so as to discuss it, let's check out an animation. Okay, we'll check out an animation. Guys, before we go, this particular question. Try cutting vegetables with a blunt knife and then with a sharp knife. Which is easier? What do you think? A blunt knife means what? A knife which has a flat surface, not pointed or sharp edges. Flat surface knife is a blunt knife. And one particular knife which we have is a sharp knife, pointed surface. So as to cut vegetables, which one is more convenient or easier? Blunt knife or sharp knife? Madhav has shared the answer as sharp knife. Guys, type it down, everyone. I want the responses from everyone, not just one or two. Everyone in the meeting should type the responses in the chat box. I don't want anyone sitting idle over there without responding in the chat box. Real quick. When I ask you something over there, over here, you should not be like, oh God, my answer will be wrong or what. No, it's completely fine. You can drop your answers. Give a wild guess, because this particular thing, did I show you the animation or did I explain the answer? No, right? So you can give your wild guess. And if I ask you, should I use a blunt knife or a sharp knife? Don't answer. Sir, we can use a hammer to cut vegetables. No. You'll be away from the meeting. So guys, you know, right? Everyone has typed the perfect answer. Sharp knife, because it is sharper. Harshita is like sharp knife for sure, since it is sharper, so that it will be easier or convenient to cut the vegetables, right? Kevin, type your query in the chat box. I told you. Still hand raised or what? Type it down. Quick. Or lower your hand, or else I'll assume Kevin have a big query. Okay, do one thing. Unmute Kevin. Quick. What's your query, quick, Kevin?
Sir, actually I didn't understand contact course because last week I was not there.
Yeah, so what I am supposed to do? Take the entire 3 sessions which you missed all the way to today? No, right? You're supposed to get the link of it and watch it again. Got it? Clear? Have been repeating from the beginning of the session.
I will know, but only one topic I don't know. The contact force I don't know. What is
Yeah, what you have to do? Please do contact the admin team. Get the link, get detailed link of it. Got it? Got it? And contact force in basic terms, in simple terms, if you want to understand, is nothing but the interaction of two bodies where they'll have a contact with each other. So as an example, we have shown animation in the previous set, not just one single animation. We have discussed many animations in the previous session where two bodies will have contact with each other, and cause of that there will be a force acting on it. So this particular term is coined as a contact force. Got it, Kevin? Got it? In detail, what you have to do, get the link of it so that you'll get the detailed explanation of it. Fine. So let's go ahead. Yes, Prince sir, please go ahead with the first animation. Yes. So everyone is thinking why the girl is standing over there. The girl is saying she's hungry. Okay, I'm hungry. I need something to eat. Okay, then her mom is like, yeah, take this piece of apple, not piece of apple, an entire apple, right? So she is thinking, okay, how will I eat it? I need to cut it, right? Fine. So she took the apple to the kitchen. So yes, pause. So which instrument should she take, guys? Blunt knife, a sharp edged knife, or a hammer? What do you think, guys? Knife. Avantika is smart enough. Knife, anyways, not sharp or blunt. Anyways, you have to take a knife. Hammer. Maria is like hammer. Okay, with the hammer you will cut the apple or what, Maria? So here obviously she'll take, if she is wise enough, not like Maria, what she'll do, she'll take a sharp knife for sure. Yes, Rinsa, go ahead. So here she'll be taking a sharp knife so as to cut this apple, right? Fine. So let's see what happens. She took the sharp knife, smart enough, fine. So she tried cutting it, let's see what happens. Okay, she chopped it into 2 pieces, 2 different pieces. Okay, easy, now I can eat it peacefully. Now what if she tries it with a blunt knife? What will happen? Will she be able to cut it peacefully? Or will it be tough? Okay, she's trying it. Is it possible? No, right? It's tough. It's not possible. So what happens? When she took the sharp knife, she was able to cut it properly. What is the reason for it? Yes, Rinsa. So guys, what do you think? What is the reason for it? Why she was able to cut the apple peacefully using a sharp knife and not with a blunt knife, or what? Anyone? What do you think? Why she was not able to cut it? The blunt knife. Who will be answering me? Unmute.
Ashika.
Okay, Ashika. Before unmuting you, please do make sure there is no background noise. When I unmute Ashika, know what happens? I feel like I'm on a DJ party over here. So unmute Ashika. Ashika is like, okay, then I won't unmute. Go ahead.
Yes, sir.
Okay, Ashika is like, yes sir, I do understand, a lot of background noise coming up. So go ahead, what do you think? Why is she using a sharp knife?
Because you can cut it easily and faster with less time without using so much pressure.
Without using much pressure, we are able to cut it easier. I am asking you why? Why is that possible?
Because sharp is like
So,
knife is sharp.
okay. So what you have to do, there is an option down there. You can mute yourself, Ashika. Fine. So guys, the thing is, over here, for a sharp knife, it is pointed, right? Lesser surface area. So if we have greater surface area, what will happen? The pressure which we apply on it will get spread over it, right? When she is using a sharp knife, lesser surface area means all the pressure is acting on the knife will be pointed to that particular sharp edge. So end of the day, it will be easier to cut. Got it? So unmute Laksha. Yes, Laksha Kumar, give me your answer.
Yes, sir.
So what do you think, Laksha?
I think we are applying pressure.
Yes, okay. We are applying pressure for sure. Laksha, tilt your camera a little bit down. I can't see your face. Yes. So what is happening, Laksha?
Things.
So we obviously will be applying some pressure to cut it for sure. Then why she didn't use a blunt knife or a hammer? Why did she use a sharp knife itself? What is the reason?
It sometimes was sharp edge.
Come again?
It had a sharp edge.
It
The center was sharp edge.
sharp edge. Okay. So other objects will not doesn't have any sharp edge or what? So cause of that, this sharp edge knife will or the sharp knife will help. It will be easier for her to cut the apple, right? So
Yeah.
why is it easy for her?
Pressure and some.
The pressure exerted on the knife will be concentrated to a lesser surface area, right? For a sharp edge. Got it? So all the pressure will be acting on its sharp edge. So greater pressure means what? Easily the apple will be chopped into pieces. Got it? So wider surface area, blunt knife will not have that much sharp edges, right? So wider surface area, what will happen? The pressure which we are applying on the knife will get spreaded. Got it? It won't be concentrated to a particular area. Clear? Clear? Fine. So Abhirami, do you have an answer to give? I saw your hand raised. I know you have some answer in your mind. Go for it. Abhirami. Yes, Abhirami, what do you think?
We do use pressure for like everything, but then when we use that type of knife, then like we can use less pressure on it because
Okay.
it is sharp edge.
Yeah, since it is a sharp edge, with applying less pressure, we can cut it easily. So that is why she took the sharp edge knife. Fine. Diplomatic answer. Good. Fine. So guys, over here, this is the reason. Since the surface area is less with respect, yes sir, with respect to the sharp edge knife. So cause of that, she used a sharp edge knife which helped her to cut the apple or chop the apple into pieces easily. So basically, we are going to discuss about pressure, that is the force acting on a unit area. Everyone, pen down, focus over here. I'll tell you when to write. Pen down, focus over here. Okay? So when I give something over here, first try to understand what we are trying to learn. Get it in your mind, understand the concept. Then you can write down in your notebook. Clear, everyone? Note ahead, clear? I'll not say this next time. When I show you something over here, don't directly go and start writing. No, I'll give you time, don't worry. Okay? So pressure is the force acting on a unit area of a surface is called pressure. Okay? When we are applying some pressure on a particular surface, we'll be calculating the pressure applied with respect to the unit area. So pressure is termed as the force acting on a unit area of a surface. Got it? So with respect to this definition, we can define pressure with respect to as an equation as pressure is equal to force divided by area. Okay? Pressure is equal to force divided by area. Guys, this is important. Okay, this is important. Pressure is force divided by area, and using this equation you can understand that area and pressure is inversely proportional, right? Can you see? Because area is in the denominator. Got it, guys? When something in the denominator increases, this particular value will decrease, right? And this increases, this value decreases. So as the area increases, the pressure decreases. As the area decreases, pressure increases. So that is the case. In the case of sharp-edged knife, the area was less, so the pressure was greater. So with applying less pressure, we can have more effective way. We'll get a more effective result. Got it? So greater surface area means the pressure acting on it will be supplied to different areas. So the effect of it will be less. So as the area increases, pressure will be reduced. As the area decreases, pressure will be increased. So can you see over here? Inverse relation. So please do remember this equation. Pressure is equal to force divided by area. Pressure will be exerted by liquids and gases as well. So we'll learn about these liquids and gases. Please don't worry. So you don't have to write this. You just have to write the equation of pressure and this definition. These first 2 points, write it down quick. Pressure is equal to force divided by area. So put it in a box, important equation, mark it as important. Pressure is equal to force divided by area. Very, very important. So what is the star? Just marking it as important, and then it's not required. You don't have to write it. So just keep it in your mind. Pressure will be exerted by liquids and gases as well. So we'll learn how the pressure is exerted on a liquid or gases. So all these for all these things, we'll check out animations with activities. We'll learn about it in detail. So as of now, please do remember this. And once you're done writing, please do let me know. Quick, real quick. Guys, done? Once you're done writing, give me a thumbs up. Bhadra is done. Who else is done? Madhav is done. Anugrah is done. Guys, once you're done writing, give me a thumbs up. There is a thumbs up emoji down there, right? Reactions. So please do drop it. Let me know so that I'll understand. Okay, Meghna is done. Fine, so that I can go ahead. So everyone done, right? Can we go ahead? Nod ahead. Fine. Fine. So why porters? Porters means you know, right? The one who carries weights, the one who ports, for example, luggages or goods. The porter will be taking it from one position or one place to another by lifting it on his head, right? On his or her head. So why porters place a round piece of cloth on their heads when they have to carry heavy loads? What do you think? What is the reason for it? When they have to carry heavy loads, why porters are keeping a round piece of cloth on their heads? What's the reason for it? Any guesses? Ashika is like, I want to answer. No, Ashika, I won't unmute you. So this time we'll give a chance to Anugraha. Ashika is like, I want to answer. I wanted to answer. You won't unmute me. Next time, Ashika, for sure. Next time I'll give a chance for you. Unmute Anugraha. Yes, Anugraha. What do you think? Why do they piece?
They keep a round piece of cloth on their head because it will reduce the amount of pressure of the load on their head.
It will reduce the amount of pressure acting or load acting on their head for sure. So what is the reason for it? How is it reduced? Any idea?
The surface of the load, the whole surface will not be on the porter's head.
What? Come again?
The whole surface of the load will not be completely on the porter.
Fine. Still more justification is needed. Anyways, good try. Unmute Kevin. Hi Kevin. Ashika is like, sir, I want an answer. This time I'll rock. Yes, Kevin.
Yeah.
Yes, Kevin. What do you think?
Sir, I think because if we don't keep a piece of cloth on our hair, we will feel more pressure.
We'll feel more pressure when we piece of cloth. When we place a piece of cloth, what will happen?
When we don't keep the piece of cloth, and when we take the heavy roads, we will feel more pressure on our hair.
Okay, when we are not placing the piece of cloth, we'll feel more pressure on our head.
Yes.
Reason?
What's it?
Reason. What is the reason for it? Reason, I don't know. So Ashika will be answering me. Yes, Ashika, unmute yourself.
Sir, the pressure reduces on the quarter, sir, as the area of contact decreases.
As the area of contact increases, as I have discussed, very good Ashika, as I have discussed with respect to surface area, when the area increases, the pressure decreases. When the area reduces, pressure increases. So over here, when he is placing a piece of cloth, the area of contact with the load and his head increases. Without placing a piece of cloth, what will happen? Our head will be like this, right? So only a point will have a contact with the load. So it will be tough. When we are keeping a piece of cloth, the entire piece of cloth will have a contact on the load with the pot which the potter is lifting. So when the area of contact is increasing, the pressure acted upon it will get spreader, right? Which means greater surface area, pressure will get reduced. So that is why potters place a round piece of cloth on their heads when they have to carry heavy loads. So Joshlin, right? Joshlin was about to answer. So I'll give the next question to Joshlin. By doing this, they increase the area of contact of the load with the head, so the pressure on the head is reduced and they find it easier to carry the load. Clear, everyone? You want to write it or what? Yes, Joshlin, do you have any different answer, different thought process or what? Same answer, right?
Same answer, sir.
Fine. So guys, please do note it down if you feel like to note it down. It's not something which you have to memorize thoroughly. It's something which should be there in your mind already. Should have this answer in your mind. You have to apply the logic which you have learned with respect to the pressure. That is, pressure is equal to force divided by area. So please do remember the equation again. Important. Pressure is equal to force divided by area. Important. We have learned this already, but still, just for your reference, I'm writing it over here. Pressure is equal to force divided by area. So guys, if you feel like you will forget it, you can note it down quick, real quick. Once you're done writing, type done in the chat box. Okay? So in the meantime, Rinsa will be making me invisible. Guys, once you're done writing, type done in the chat box. Then only I'll come back. Okay? Or else I'll make myself invisible in the whole session. Yes, Rinsa. Go ahead. Yes. Everyone done or what? Everyone done? Can I come back? I don't see much done in the chat box. Only 5-6 dones. Joshlin, Anugrah has responded. Fia has responded. Badra, Avantika, Maria, Ria. Okay, some responses are coming. So should I come back? Yes, Rinsa. There you go. Yes. Fine. So everyone is done. Everyone has done, I guess. So let's go ahead, guys. So can you explain now why shoulder bags are provided with broad straps and not thin strap? Shoulder bags or your school bags, it'll have a thick strap, right? Or broad strap, right? Broad, not thin one. Why we have a broad strap? Why don't we have thin straps? What is the reason for it? So unmute Joshlin. This time Joshlin will answer. Yes, Joshlin, what do you think?
So like school bags have broad straps so that the area of contact on your shoulder, the area of contact increases, so the pressure reduces on your shoulders and your hand.
Very good, very good. Since we have broad straps, the area of contact will be greater, right? So greater surface area means what? Less pressure. So the pressure exerted on our shoulders will be spreaded or will be splitted, or what we say, it will be given to all the areas since we have broad straps. So the area of contact is greater for broad strap compared to that of a thin strap. That is why the shoulder bags are provided with broad straps. Fine. Now let's go ahead with the next question. Why the tools meant for cutting and piercing always have sharp edges? What is the reason for it? Why do they have sharp edges? Everyone knows the answer, right? We have discussed this with an animation. So unmute Avantika. Hi Avantika, what do you think?
Yes, sir.
Yeah, let me know why. Why the tools meant for cutting and piercing always have sharp edges? Why not broad edges like the straps of bags?
When the area of the edge decreases, the pressure gets increased.
Pressure will increase, right? When the area of contact decreases, the pressure will increase on that particular area. So obviously, tools meant for cutting will have sharp edges so that we can easily cut, so that we can apply greater pressure on it. Since it has a very less area of contact, that is why we have sharp edges for the tools meant for cutting. Very good, Avantika. Fine. Unmute Madhav. Madhav, Madhav, do you have a different answer or the same answer?
No, sir, I was going to say the same.
Yes. So Madhav is like, yeah, sir, I knew the answer. I was about to say the same. Yes, Rin, sir. There is a deflection over here. Yes. Over here. Yes. So pressure exerted by liquids and gases. Guys, can you go ahead with the pressure exerted by liquids and gases? So till now we have learned with respect to the surface area, where the pressure will increase or decrease. So when the surface area is greater, the pressure will decrease. When the surface area is lesser, the pressure will increase. We have learned that. And when we have learned pressure, I told you a point. Which one? Pressure will be exerted by liquids and gases as well. So liquids and gases will also have pressure on it. So pressure can be exerted, or pressure will be exerted by liquids and gases as well. Let's check out how pressure is exerted by liquids and gases. Okay? Fine. So let's go ahead. Yes, Rinsa, let's go ahead with the first animation. Let's check out an activity. For example, how pressure is exerted by liquids. So for the pressure exerted by liquids, let's check out an animation so that you will have better clarity of it. Yes, Rinsa. So over here, what are we doing? We are considering a table, okay? We are considering a table over here. Yes, Rinsa. Can you please me a little bit left? Yes. So guys, what are we doing? We are taking a test tube, right? Okay. We are taking a bigger test tube. Okay, fine. Yes. So we have considered bigger test tube. Then what will happen next? So over here we have considered a container of water. So test tube will have a height of 25 centimeters. Fine. Then what will happen next? Let's check out. So over here on top we'll have 5 centimeters. So the length of it is 25 centimeters. So what are we doing? We are placing a balloon in its bottom. Okay, its bottom part is open. What are we doing? We are tying a balloon. So both ends are open anyways. Both of its ends are open. But on the other end, what are we doing? We are fixing a balloon over it. So now it's closed with the balloon. This end, the other end is open. Now let's take this amount of water and add it to the test tube. Let's see what happens. Yes, Rinse. So we'll be taking this container of water. So we are adding the water into it. So let's see what happens. Can you see, guys? The size of the balloon is increasing, right? Can you see over here? The balloon is bulging over here. So what is the reason for it? Everyone type it down in the chat box. Why the balloon got bulged when I have added some water to the tube? When I have added some water to the glass tube, why the balloon is bulged? Why the balloon size has increased? So everyone is typing pressure. Yes, pressure. The water filled the balloon. Yes, Navneet, water filled the balloon for sure. But what happened? Yes, exactly. Madhav has given a distinctive answer. Water exerted some pressure. The amount of water and pressure in the tube. Yes, not just the amount of water, but why the pressure in the tube is there? The pressure in the tube got transferred into the balloon, right? Why? By the effect of the water which we have added. So the liquids are applying pressure on the walls of the balloon. So the balloon size is increasing because balloons have a rubbery expandable material, right? So when we are adding some water into it, what happens? The water will exert some pressure to its walls. So here, since we are using a tube, the pressure inside the tube gets transferred into it. So the pressure inside the tube over here the pressure inside the tube will reduce and the pressure inside the balloon will increase. Why? There will be a pressure difference when the pressure will be transferred from a lower partial pressure to greater partial pressure. You will learn about it in detail in your higher grades. As of now, you have to understand that when we tie the balloon to this tube, to this glass tube, when we add some water on it, the water added to the balloon gives some pressure to the walls of it. So in simple terms, what you have to understand, liquids exert some pressure to its walls. Okay, so pressure is exerted by liquids as well. Got it, everyone? Clear? This simple aspect clear? Fine. So yes, Rinsa, you can remove the animation. Fine. So guys, can we check out one more animation? Yes. So Rinsa, please go ahead with the next animation. Yes. So over here, yes, Rinsa, can please take down the number and the name down here. Yes. So over here, you can see that we are taking a plate and we are considering a bottle of water, right? So everyone is thinking, okay, where is the water? Anyways, we are considering a bottle and we are keeping it on a plate. Why we have considered this plate a tumbler? Why? What is the reason for it? Just because we'll be trying to add some water on it. So if the water gets spilled out, it will be saved in this plate kept over here. It will not be wasted outside. So that's why we are keeping it. Anyways, yes, Rinsa, go ahead. What will happen next? Let's see. Yes, Rinsa. So what are we doing? We are adding some pores into it. We are adding some pores to the bottle. Why? Everyone is thinking, why should we add some pores to the bottle? Now everyone will go to the kitchen or to the dining table and take their water bottle and put some pores, right? No, please don't do it. Everyone will be telling, my tutor told, put some pores to the water bottle so that we can have fun. No, right? Fine. So we'll check out why we have added some pores to it. Yes, Rinsa, please go ahead. Fine. So over here, let's see why we have added some pores. Okay. So who came? We can call him Anup, right? So over here, my friend Anup came over, and what is he doing? He's adding some water to the water bottle. Okay? Yeah, he's adding some water to the water bottle. Fine. Yes. So when he has added some water to the water bottle, what happens? The water spills out through the pores like a fountain, right? Water spills out through the pores like a fountain. and we are saving the water over here in the plate, right? Anyways, so what was the point we were trying to prove from this activity? This activity is given there in your textbook. The previous activity was also there in your textbook. What is the reason for this particular activity? Why did we put some pores and try to add some water? And why did we, okay, everyone will be enjoying the fountain, right? Okay, nice, beautiful. Just over here, we can see a fountain, water is coming out of it. We'll have fun. Everyone will put some pores, right? Water column exerts pressure at its bottom. Yes, for sure, Fia Faisal. It exerts equal pressure at same depth. Yes, because of the pressure exerted by the water. Because of the pressure exerted by the water, it gets spilled out of it, right? Yes, over here you can see that in each case, in each pause, the amount of water coming out of it is the same, right? It has same projectile, right? Is it like one pore is going like this and the next one is small? No, right? We have added equal sized holes. The diameter of it was equal. So over here, the water coming out of it is also equal. Why is that? It is just because the pressure exerted by the walls, exerted to the walls of the container by the liquid is the same, is the equal in all the areas. Got it? So over here, this is an example. This is an example for the pressure exerted by liquids, and also you have to understand that it exerts equal pressure on its walls at same depth. Yes, unmute Laksha. Laksha is like, sir, I want to add some point. Yes, you can add, Laksha.
Yes, sir.
Yes, go ahead.
Yeah, sir. When you add the cap, like it stops because the
Pressure is, what happens to the pressure?
I can't find the pressure. Pressure traps there.
Pressure drags there. So actually over here what happens, even though the pressure is exerted on the walls, when we are adding some pores of equal diameter, what happens? Equal amount of pressure is acting on the walls, right? So obviously equal amount of water will come out through the pores. That is why we can see a fountain like structure over here when we do this activity. Got it? Laksha, clear?
Yes.
Fine. So from this particular activity or experiment, we can understand that liquids also exert some pressure, or pressure is exerted by liquids as well. So this is the next example, or another example for it. So let's check out one more activity. Yes, Rinsa. Let's check out one more activity. Yes. Can you please keep me in the middle? Yes. So guys, let's see what happens. Yes. So over here we are considering a bottle, an empty bottle, right? Anyways, so over here we are considering a connecting straw or a connecting tube so that we can connect it to the bottom part of the bottle. Yes, Rinsa. Let's see how we can connect this tube to the bottom part of the bottle. Can you see over here, guys? So this tube is connected to the bottom part of the bottle and the end of the tube is connected with a balloon. Okay. Now let's see what happens when we add some water to the bottle. Yes, Rinsa. Everyone is like, obviously we know the balloon will get bulged. Let's see what happens. We are adding some water to the bottle and I've connected a tube to its one end, or its bottom end. So what happens, guys? Can you see? The size of the balloon is increasing, right? Size of the balloon is increasing. Because of what? Because of the pressure difference inside the bottle that is transferred over here. And the liquid over here exerts some pressure on the balloon or in its walls. Got it? Now, Laksha, you want to answer something, or you have a query, or you forgot to lower your hands? Forgot to lower it, right? Fine. So over here, in this particular activity also, we can see that when we add some water to the bottle, obviously there is some pressure difference over here, and because of the pressure exerted by the liquid or the water which we have added over here, the balloon is getting bulged over here. Everyone understood this particular activity? Clear? Fine. So let's check out the inferences. Yes, Rinsa. So let's check out the inferences from these three activities. So the first one, from the first activity, we have learned that pressure exerted by water at the bottom of the container depends on the height of its column. We have considered a long tube, right? Long tube which we have considered, and in the bottom part of the tube we have connected a balloon. Now in the second case, we have learned a liquid exerts pressure on the walls of the container. For sure, when Anup came and added some water, what happened? Obviously, pressure was exerted to the walls of the container when we have added some pores to it. Water was coming out of it in equal proportion, right? Now, in the next recent activity which we have checked, we have understood that liquid exert equal pressure at the same depth. At the same depth. Why? How can we get that? How can we understand that? Because when we have connected a tube to the bottom part of the bottle, still the balloon was getting bulged. Which means, in all the cases, when we have connected to its one end or the bottom part, in all these cases, the balloon gets bulged. So liquids exert equal pressure at the same depth. So please do write down these inferences. Guys, when you write down these inferences, all those three activities should be there in your mind. So from those three activities, we have got these inferences. So please do write it down real quick. Once you're done writing, please do let me know. Quick. So in the meantime, Rinsa will be making me invisible. Guys, once you're done writing, type down in the chat box. Pressure exerted by water at the bottom of the container depends on the height. Yes. Yes, everyone done, right? Okay, I got many done now. Very good, very good. I appreciate that. Hashita, Madhav, Abu Sofia and Ria Girish, lot of you are responding. Yes, done sir, done, fine. Yes, let's come back, Rinsa, fine. There you go. Fine. So let's go ahead. I hope you remember the inferences and the activities which we have seen over here. So now can you say that liquids exert pressure on the walls of the container? Yes or no? Nod your head, everyone. Let me see. Yes or no? What do you think? Yes or no? Everyone, don't sit idle over there. Let me see that energy. What do you think? Liquids exert pressure on the walls of the container, right? For sure. Yes. Now let's go ahead with the next. That is, do gases also exert pressure? What do you think? Do gases also exert pressure? Gases do that or what? So Vanisha is like, yes. Alim is like, yes, for sure. Gases also do this. Let's check it out, right? Fine. So let's check it out with some activities. Yes, Rinsa, please go ahead with the next animation. So let's check out an activity where the gas also exerts some pressure on the container or the walls of it. Yes, there you go. So here, so we can call her Meghna, right? Meghna Sunil is walking all the way to the balloon shop. Okay, Meghna is going, fine. So let's see what happens. Meghna is buying balloons, right? So how many balloons she bought? She bought 2 balloons. So Meghna bought 2 balloons. Fine. So she got 2 balloons. So Meghna is so happy. I got 2 balloons. I'm gonna rock with it. Fine. So 2 balloons she kept on the table. So let's see what she does. Yes, Meghna, go ahead. Please do something. Okay. Meghna took the first balloon and she's trying to blow some air into it. Fine. So when she has some, yes, please pause it. So over here, when she has blown some air into it and tied it, she kept over there. Okay, this balloon is filled. Now I can play with it. Now Meghna is so happy that she got another blue balloon. Now this one also I'll fill some air and I'll have fun. Fine. So let's see what happens. Yes, Meghna, please blow some air into the blue balloon as well. Let's see what happens. So Meghna is trying to blow some air. What happens? The air goes out, right? Can you see? Air goes out through the pores, right? Yes, Rinsa, please play it again. Yes, same. Till then, 2 times it's there. Till then, let it play. So over here, can you see when Meghna blows some air? Yes, Rinsa, please play it. Keep playing it. So over here, what happens? Can you see? Yes, please pause it. Can you see? Meghna, did you see? You saw it, right? What happens in the second case when Meghna tried to blow the blue balloon? Air came out of the pores in the balloon, right? Guys, were you able to see the pores? Pores were there, right? In the second balloon, blue balloon. Yes, Kevin is like, sir, I saw. Everyone saw it, I guess. So in the second case, there were pores in the balloon. So because of that small pores, what happened? The air came out of the pores. So that is why the balloon, the air was not able to, the pressure was not able to split into the walls of it. Why? All the pressure exerted by the air came through the pores. Okay, we are going away. Bye bye. But in the first case, what happened? All the pressure were exerted to the walls of the balloon. So that is why the first one was, so she was able to tie it successfully with filled air in it. So yes, Rinsa, please play it again from the beginning. Focus over here. Initially, yes, she is going to buy the balloon. Let's skip that part. Meghna brought 2 balloons, fine. So let's see what happens when she blows it. First case, she filled it with air. Why? The pressure is exerted by the air or the gases into the walls of the balloon. So its size bulged, right? Size increased. Can you see over here, everyone? Fine. So in the second case, when she tried, what happened? When she tried to fill the second balloon with air, still in this case also pressure was exerted to the walls, but what happened? The air came through the pores in it. So this balloon was a defective balloon, right? So Meghna is gonna fight with the shopkeeper or the balloon vendor. So she'll be fighting with him. So she'll be like, why did you give me a defective balloon? I'm gonna fight with you. So here in the second case, Meghna was not able to fill the balloon. So in the second case also the air pressure or the pressure was exerted by gases on the container of the balloon, but still, since there were pores, she was not able to fill it properly. Yes, Alim is sharing. In the pink balloon filled up because air was applying pressure in the balloon, making it stay in the balloon itself. So in the first case, the air was staying in the balloon itself. But in the second case, the air was coming out of it. Yes, very good, Alim. So guys, everyone understood this particular activity clear? Understood this example activity? Fine. So we'll go ahead. Yes, Rinsa. The envelope of air around us is known as the atmosphere. What is this atmosphere and all? Any idea? What is this different spheres and all? Any clarity? Fine. So we'll check out the different layers of the spheres. Yes, Rinsa, please go ahead with the next animation. Fine. Yes. Let's check out the different layers about the Earth's surface. Okay. So basically we know obviously where the air is spread over here, just on top of us, it is none other than the atmosphere, right? So over here we have different layers, that is troposphere, stratosphere, mesosphere, thermosphere and exosphere. And everyone's like atmosphere is on the top. So in the atmosphere itself, we have different layers. It's not like, okay, over here in the bottom part we have atmosphere, on top of that we have troposphere, stratosphere, mesosphere and all. No, this entire layers constitutes the atmosphere. So the atmosphere constitutes different layers. So the bottom part of it, the first bottom part of it is the troposphere. On top of that we have stratosphere, on top of that mesosphere, thermosphere, exosphere. Alright, so this entire set of layers constitutes the atmosphere. Got it, everyone? Clear? So everyone is like, we have learned this in geography. Geography, I've learned it, right? Geography, different layers of atmosphere. Fine. Yes, Rinsa, you can remove it. Fine. So yes, Rinsa, please take down. Yeah. The envelope of air around us is known as the atmosphere. The atmospheric air extends up to many kilometers above the surface of the earth. So we have learned, right? We have seen the different layers of the atmosphere. So obviously till the top part, it's n number of it extends to a great number of kilometers, right? For sure. So for sure, the atmospheric air extends up to many kilometers above the surface of the earth. Now, the next point, the pressure exerted by this air is known as what? Atmospheric pressure. So I can see Avantika is writing, guys, I told you, and I'm explaining something, focus over here. Then I'll give you time to write. So the pressure exerted by this air is known as the atmospheric pressure. We know there will be atmospheric air on top of the earth's surface, so it will be extended up to different n number of kilometers or a greater number of kilometers. So this envelope of air is known as atmosphere. But what is it? The pressure exerted by this air is known as atmospheric pressure. Now, atmospheric pressure is the force of gravity on air in a column of unit area. This is the advanced definition of it, not important. So these 2 points are important. The atmospheric air extends up to many kilometers above the surface of the earth. The pressure exerted by this air is known as atmospheric pressure. Now please do note it down, these 4 points. Go ahead. So guys, is it clear before noting down the points? Is it clear? The concept is clear or what? Fine. So please do remember the layers of the earth as well. Even though it's not there for physics, it will be helpful for geography, right? Fine. Or social studies or other subjects, it will be helpful for you guys. Anyways, please do note it down. The envelope of air around us is known as the atmosphere. The atmospheric air extends up to many kilometers above the surface of the earth. The pressure exerted by this air is known as the atmospheric pressure. Now, the atmospheric pressure is the force of gravity on air in a column of unit area. Write down, guys, real quick. Real quick, write it down. Once you're done writing, do let me know. Everyone is thinking, why sir is not going invisible? Sir, it's time to go invisible. Go ahead. So I just want to share this. Yes. So Abhirami wants to share some information, guys. Abhirami wants to share that in the stratosphere, the aeroplanes and all fly because there is no disturbance there and perfect for flying the plane, and also it is 30,000 feet up. Yes. Over there, the pressure difference will be less, right, in the stratosphere. So it will be very comfortable for the airplanes to fly over there. That is why the airplanes will be flying in the region of stratosphere. In the case of atmosphere, we have learned in the case of atmosphere, we have different layers, right? Troposphere, stratosphere. So on top of troposphere, the flights or the airplanes will be flying over there, since there is less disturbance. Less disturbance means what? Less turbulence, or the air pressure difference is less. So that is an advanced concept. So as of now, this is the basic information shared by Abhirami. Thank you, Abhirami. Fine. So Shika is done, Harshita done, Anugraha done. Fine, very good. Everyone done or what? Can we do? Go ahead, quick. Sarah is like, no sir, I'm writing, quick. Write it down real quick. Madhav done, Maria done, Ashika done. So guys, once you're done writing, what you'll do, you'll sit like this and think about Mr. Bean, Tom and Jerry. No, right? What you'll do, try to revise, try to understand, try to read the topic, read the points again. Now register it in your mind itself. Later you don't have to work on it, right? Later what you have to do, you have to put some extra energy on it. No, learn it right away. Try to read the points which you have written in the notebook. Get it in your mind. Make it very useful. Let me know if you have any queries or doubts. Let's go ahead, guys. Done. Sarah is like, yeah, now I am done. Now you can peacefully go ahead. Kevin, done or what? Quick. If you're not done yet, what I'll be doing, I'll be asking you to take a screenshot. So always, I don't appreciate screenshots, but just for the time being, if you feel like, oh, you're gonna miss it, so it's gonna go ahead. In that case, you can take a screenshot. Okay, Kevin is like, no, no, I don't have to take the screenshot. We can go ahead. So Ashita and Ashika is like, sir, exam, when is the test? So before we go to the next test, let's check out 2 more animations. Yes, Rinso, let's check out the next animation. Yes. Please go ahead. Yes. So guys, what are we doing? We are taking a container, right? Fine. So let's see what happens. We're taking a container. So on top of it, in the glass container, what are we doing? We are adding some water into it. Fine. I have added some water into the glass container. Now, let's see what happens. Yes, friends. So over here, when I've added some water into the container, so next, what should we do? What should we do next? Over here, guys, what is this layers or arrows? Over here, like in the case of atmosphere, we have learned, we have different layers, right? Troposphere, stratosphere and all. And as Abhirami shared, in the case of stratosphere, disturbance or the air turbulence or the atmospheric pressure difference will be less. In the same way, in the case of the water added to a container with respect to the different layers, the pressure exerted will have a difference. On the top layer, it will have a greater pressure difference or less pressure difference. Less, right? On the bottom part, it will have greater pressure difference. So that is this particular activity depicts. So with respect to each layer, so it will not be like, okay, we'll draw some line. No, it's just that if you consider an particular amount of water, it will have a particular set of layers which will have different set of air pressure in it. Got it, everyone? Got it? So as to understand this, we have considered this activity. Yes, Rinsa, please go ahead with the next activity. Yes. Let's check out one more activity, guys. Yes. So over here, what are we doing? We are considering a glass table. Okay, I'm considering a glass table. Now let's see. Over here, what is this particular thing over here, guys? A sucker, right? We're considering a sucker over here. So this sucker, this sucking tube. Over here, this sucking tube. Everyone, have you tried? Have you stick something to a glass or your cupboard or something on the wall? Have you ever stick something into it? With a sucking, sucking tube or sucking, rubber-like material. So using that, what is happening? Over there, obviously there is an air pressure difference inside it when we are trying to stick it. Yes, friends. When we are trying to stick this sucker onto this glass table, what happens? There is an air pressure difference inside it. So when we're trying to push it, when we're trying to stick it, what happens? The air inside it goes away, right? Goes away. So there is less pressure inside it. Got it? So when we are sticking it or when we are trying to pull this less pressure difference inside it makes it stick into the glass table itself. What happens when we try to pull it? The air outside it will have a tendency to get inside, right? So this less pressure difference will have a tendency to stick over there itself. That is why, and even though when we try to pull this sucking tube over here, what happens? Still, we won't be able to do it. It'll be tough for us. So that's the reason. So this is also a perfect example for a pressure difference with respect to the air pressure. So this is a particular example of it. So in detail, you'll learn about it in higher grades. So as of now, what you have to understand, over here there is a pressure difference, and because of the pressure difference, you are able to stick this sucking tube over here to the glass table. Not just the glass table, on every flat glass surfaces, you can use such materials, right? Have you ever tried? Now from now on, you'll be educating your siblings and parents, right? So over here, this is the reason behind this sucking tube or sticky materials will be there, right? Connected to this such sucking tubes. So you'll have something, some sucking tubes where it'll be used to hang things, hang keys and all. You guys use this, right? So this is an example for it. Yes, friends. So from these two activities, we have learned when you press the sucker, most of the air between its cup and the surface escapes out. So there is a less pressure difference inside. So the pressure difference makes it stick into it. So the sucker sticks to the surface because the pressure of atmosphere acts on it. So please do note it down. So educate yourself, so it will be very helpful for you. You can share it to your siblings or parents. Yes, Sarah, we'll have the test right away. Don't worry. Sarah is very concerned. Sir, when will we have the test? For sure. After this particular topic, we'll go ahead. It's done almost. Have you ever used a sucking tube, stick to the wall to hang something, or to put some weight on it? Have you seen? Yes. Madhav is like, yeah, I have used it. Madhav, done writing? Fine. Quick. When you press the sucker, most of the air between its cup and the surface escapes out. The sucker sticks to the surface because the pressure of atmosphere acts on it. Fine. Once you're done writing, type done. Ashika is done writing, right? Fine. Kevin, are you writing? Fine. Madhav done, Abhirami done, Avadika done, Maria done. Quick, how many of you are done writing? It's not like you will be always writing the points. No, you should have the concept in your mind. Okay, so let me show you a better example for the sucker tube. Yes, Rinsa, can you please play the last animation 43? So with the use of sucking tube or a sucker cap, a sucker cup, what will happen? We can hang objects on it, right? Can you see? Sucker cap sticks to the wall. Yes, Rinsa. So we can put some weight on it, right? We can put something hanged on it. Can you see over here, guys? We can put some keychains or we can put some weight on it. So it can balance some elongated weight over it because of the sucking tube which we are using, or the sucking cap which we are using, or we will be sticking it to the walls of it because of the air pressure difference inside the cap and the surface. This is happening. This is why it is able to hang, or it is able to bear the load or the weight over here. Fine. Yes, rinse. So can you please play the 40-second animation, guys? Yes, guys. Yes, yes, this one. So guys, this is a particular add-on. Yes, please play it. So this is a particular add-on information. This is given in your textbook but not required for your exams. So there was a scientist named as Otto von Guericke. So what did he do? He took two sphere-shaped pieces. Okay, two sphere-shaped pieces he took, and he has sucked the air inside these hemispheres. Okay, this hemisphere. Hemisphere means what? Half of a sphere. You know what is a sphere, right? Circle, globe-like structure. So he took two hemispheres, and what did he do? Using a sucking tube, he has sucked the air out of it, and now he has sticked it together. So the air pressure difference is high, right? So it will be stick together for sure. Now what did he do? He tied it. He tied these two hemispheres, big hemispheres he's considering, and he has tied it to different set of hoses. And both the set of hoses are trying to pull it from both the ends. Still this hemisphere were not going apart. So now do you understand the amount of air pressure difference such sucking property can enact over here? So this is a particular example for it. This is an add-on information given in your textbook but not mandatory. Such questions will not be there with respect to Otto von Guericke, with respect to that particular scientist experiment or theory. You don't have to learn about it. As of now, this is just an example. What you have to take it in your mind? This air pressure difference with respect to a sucking tube or this particular property will have a greater value, will have a greater influence. That is why these two set of forces are not able to make this hemispheres apart. Got it, everyone? Nod your head. Got it? Fine. So just for your information, I've shown this animation. Now this chapter is done. Everyone happy, right? The chapter force and pressure is done. Don't be happy. What we'll do in the next session, we'll have the entire revision of the chapter, and we'll have the question answer session, and we'll have an exam. We'll have a detailed exam for it. So as of now, based on today's session, we'll have an exam time, right? Yes, everyone go back from the Zoom application. Please don't close it. Please don't leave the meeting. Just minimize it and go to the exam tab and submit your responses real quick. Go for it. Submit your responses. Go to the exam tab. Okay, fine. So Narasimha says that he had some technical difficulties. That is why I was rejoining. Fine. So please do inform our admin team, Narasimha, not just to the support tutor. Please do inform it to our admin team or our academic counselor team. So guys, go back from the Zoom application. You'll have a tab for the exam, right? So click on the exam tab. There will be exam scheduled over there. So click on it and submit your responses and let me know once you're done with it. Quick. Okay. Leksha is like, yeah, I can see. I've clicked the tab. I'm submitting the responses. Guys, easiest questions. Easiest questions. Mostly the questions are based on contact forces and non-contact forces. You have learned about it already in the previous session, right? Easiest questions. Submit your responses real quick. So Maria, Shija, Soni has submitted. Very good. Appreciate those who submitted real quick. Because you know the answer already. Even when you see the question itself, you know the answer. You don't have to look at the options, right? Fine. So Maria is sharing, sir, I got 10 on 10. Very good. Alim Vishaju says that he got 10 on 10. Very good. Bhadra 10 on 10. Very good. Rehan done. Fine. Sarah 10 on 10. Fine. Meghna done 10 on 10. Fine. Go, guys, quick. I gave you just the time. So the time limit is just 5 minutes. Then 5 minutes, you have to do it real quick. Navneet got 8 on 10. Guys, real quick. Yes, type your concern. Aurelia, right? Aurelia. Type your concern in the chat box, quick. What's your concern? Type it down in the chat box. Or else unmute Aurelia. Yes, Aurelia, what's your concern? Judy, ma'am. Yes, Aurelia. Unmute yourself.
Sir, you get the link.
It is not the Google form link. You will have an exam tab when you go back from the Zoom application. In the app interface or in the web page itself. Don't close the Zoom application. When you minimize or when you go back, you'll have an option for it. A blue tab is there, right? No, Abhirami. We'll discuss the question. Wait a second. Kevin got 8 on 10. So guys, the time is up. Let's get on to the questions. Aurelia, if you still have some concerns, please do contact our admin team or type your concern in the chat box. Quick. Or please do get the help of your parents, and please do let me know if your concern is not yet cleared till now. Fine. I'll type it down. So the first question was, the pressure which is exerted by air around us is known as. Everyone knows the answer, right? First option, second one, third one, fourth one. Show it to the camera. You don't have to raise your hand. Show it to the camera. Everyone shows the victory sign. Pressure exerted by the air around us is nothing because of the atmospheric pressure. So the second option is the right answer. That is atmospheric pressure. Now, during dry weather, while combing hair, sometimes we experience hair flying apart. Force responsible for this is force of gravity, force of friction, electrostatic force, magnetic force. know it, right? Electrostatic force, everyone is showing the third option. Now, force acting on per unit area is called force acting on per unit area. Contact force, non-contact force, force pressure. Everyone knows force acting per unit area is none other than pressure. We have learned it. The fourth option is the right answer. We have learned the equation. Pressure is equal to force divided by area. Now, two objects repel each other. This repulsion could be due to friction force only, electrostatic force only, magnetic force only, either a magnetic or an electrostatic force. Which one? First option, second option, third option, fourth option. Very good, everyone. I thought in this particular question you will make a mistake. So I guess most of you have given the correct answer. That is none other than the fourth option. Either a magnetic or an electrostatic force. Why? Because in magnetic force also there is repulsion, right? Two objects repel each other. And electrostatic force also, if you have equal same number of charges, it will repel. I told you, like charges repel or like poles repel. So in magnetic force, either in magnetic or in electrostatic force, we'll have a repulsive force or repulsion. Now, which force always opposes motion? First one, second one, third one, fourth one. Which one? Maria? Oh no, not Maria. Sarah, Shija. First one. Magnetic force opposes motion. No, right? Everyone is showing the third one. Yes, Sarah got confused, I guess. So the third option is the right answer. That is the frictional force. Frictional force will always act in the direction opposite to the motion, right? So which force always opposes motion? Is none other than the frictional force. So the third option is the right answer. Okay, frictional force is the right answer. So that's all for today, guys. So before we wind up, any questions, queries, concerns? Ashika, do you have any query or you forgot to lower it? Fine. So that's all for today, guys. If you have understood all the portions which we discussed, all the topics which we discussed today, give me a double thumbs up to the camera before we wind up. Let me see that energy, guys. It's not like, okay, you'll be giving double thumbs ups. No, you have to revise all the portions which we learned today. I'll be asking you questions in the next session. Not just this particular day. You have to study the entire chapter. In the next session, I'll be asking you questions based on the entire chapter. Those who were not there in the first few sessions, please do contact the admin team. Get the link of the live sessions recording. Okay, so in the next session, we'll have a question and answer session of the entire chapter. So Fia Faisal is sharing, bye sir, your session was interesting, thank you. Advanced Eid Mubarak for everyone. Advanced Eid Mubarak wishes for everyone. So that's all for today, guys. Thank you and have a nice day. Bye.